Now that we've had a chance to practice graphing or inequalities, let's go ahead and practice solving them and then graphing them. So our first thing is going to be to solve that first inequality. So we have here 7b minus 5 is greater than or equal to 65. So I'm going to go ahead and add 5 to both sides. To get 7b is greater than or equal to 70, divide by 7. To get v is greater than or equal to 10. Our next step is going to be to solve that second inequality, which is negative 3v minus 2 is greater than or equal to negative 2. We're going to add 2 to both sides, which gives us negative 3v is greater than or equal to 0. Divide by negative 3, which is going to give us v. Now I have to flip the sign so it's less than or equal to 0. And then finally our last piece is going to be to graph it. So if we go ahead and number our number line, we need to be between 0 and 10. So I'm going to put 0, 2, 4, 6, 8, 10. And then I see I need closed circles at both 0 and 10. And now when I go ahead and highlight, I see that v is greater than or equal to 10, so that's going to be to the right, and it's less than or equal to 0, so I'm going to shade to the left. Likewise, let's try another example. Let's first start off by solving 3n plus 2 is less than negative 2. So we're going to start by subtracting 2. I apologize. Subtract 2, which is going to give me negative 4. Oh, I apologize. I screwed up here. Plus 7n. So if we subtract 2, we'll get negative 4 plus 7n is less than 3n. And then we subtract 7n, and I know we usually say to keep the n's positive, but here, if we bring the, I know a lot of you struggle with graphing, and so if we put the n's on the right, on the left, it'll make it easier for your graphing. So we get negative 4n is less than negative 4, and we'll divide by negative 4, and that gives us, we have to flip the sign, and we get n is greater than 1. Now if we go ahead and solve the other one, 8n minus 4 is less than or equal to 3n minus 4. Subtract 3n, and gives you 5n minus 4 is less than or equal to negative 4, carrying that negative with it. Add 4 to both sides. We get 5n is less than or equal to 0. So we divide by 5, and we get n is less than or equal to 0. So now if we want to go ahead and number our number line, we have to go from 0 to 1. So I'm going to put those right in the middle. We need an open circle at 1. We need a closed circle at 0. When we go to shade, we have n is less than 0 or equal to, and we have greater than 1, and therefore we are done. The last piece we have is talking about some special solutions. So we have here, we're first going to start off by solving these. So we have 2y plus 7 is less than 13, so we'll start by subtracting 7, which gives me 2y is less than 6. Divide by 2. And you get y is less than 3. And then over here, you start by adding 2, which gives us negative 3y is less than or equal to 12. And then we divide by negative 3, which means we need to flip the sign. So we get y is greater than or equal to negative 4. So we'll go ahead and put our numbers down here. We have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. We have an open circle at 3, and we have a closed circle at -4. Some of you might be already seeing the issue here. So I'm gonna do, when I do my shading, I'm gonna highlight in 2 different colors to kind of get you to see the overlap here. So we have y is less than 3, which is gonna be this way, which goes through -4. Then we also have y is greater than or equal to -4. Now the big issue you might be seeing here, you might be going, well, this was an open circle. And the thing is that we need to have an or statement. And this would say that we are saying that here we have 4 included, and that's okay because it was a closed circle. Our big issue is going to be here because it was an open circle. But if we put in our statement here, because of this or, this is saying that either 3 is less than 3 or 3 is greater than or equal to -4. And in our case, this part here is true, which makes the whole compound inequality true. And as you can see, that therefore makes the entire number line highlighted. So this is where we would have the opportunity to say that this is all real numbers. And I mentioned this in 4th hour, you can make your all real number symbol by making 2 bars for the down part of the R and then make an R, and that will suffice. Let's take a look at a special solution now for and inequalities. So we have here 1 minus 4x is less than 21 and 5x plus 2 is greater than or equal to 22. So when we solve this, subtract 1 and we get -4x is less than 20, and then we divide by -4, which is going to flip the sign, giving us x is greater than -5. Then on the other side, we subtract 2, and we get 5x is greater than or equal to 20, and divide by 5, and we get x is greater than or equal to 4. Now this, remember, is an and inequality, so it has to be where we deal with the arrows. So the first thing we're going to do, we go from -5 to 4, so we'll number this. So -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, we'll go 5 here as well. We need an open circle at -5. We need a closed circle at 4. And this is where our arrows come in because it's that overlapping of the Venn diagram where we need to have both occurring. X needs to be greater than 5, so we're going to the right. But x also needs to be greater than 4. And I had a couple of you ask me about this. So if we were to shade for 5, we would shade, and I'm going to show you in a color. We'll start with yellow. That goes here. And then if we shaded for x is greater than or equal to 4, that is here. So what we need is only where the double highlighting is. So that means that we're going to actually get rid of this highlighting here. And we're only going to highlight from 4 on up because this is an and inequality. Therefore, because it's an and inequality, we want to make sure we have the double overlap. So here are your U-try problems, and you are going to solve and graph, if you are able to, both of these problems and bring them to class tomorrow.